Hi class, this is chapter 6. It's over project time management, and we'll see what the significance of time management is with project management. So we're going to understand the importance of your project schedules and good project time management, and discuss the process of the planning the schedule, and look at the activities for developing those project schedules. Also to look at how project managers use network diagrams and dependencies to assist in activity sequencing. And then we'll look at the relationship between estimating resources and project schedules, and how various tools and techniques help project managers perform activity duration estimates. And that is, how long is it going to take you to perform or complete a specific task in your work breakdown structure. And here's our learning objectives for part 2. We're going to look at Gantt charts, PERT charts, look at agile process, how reality checks and discipline are involved in controlling and managing changes to that project schedule, and how project management software can assist in managing your time, and we'll talk a little bit about that, different kinds of software. Okay, so the importance of project schedules basically is you need to know what you have to do and when you have to do it, and then how you keep up with the status and your progress of to make it a successful project. So managers often cite delivering projects on time as their biggest challenge. So time has the least amount of flexibility, and it's very important on a project. And schedule issues are the main reason for conflicts, especially during the second half of the project. Okay, so individual work styles, and this comes with your teams. You have different types of people in your team, different attitudes, and a dimension of Myers-Briggs type indicator focuses on people's attitudes towards structure and deadline. I believe there's a link to some Myers-Briggs assessment tools, so you can go in and try to determine what type you are, and maybe talk to your team members, find out what types they are. And so if you know the actual type indicator for people, you know how to manage them. Okay, some people prefer to follow schedules and meet deadlines, while others do not. And that's a J type versus a P type. So check out the Myers-Briggs. That's very interesting. And you might even learn a little bit about yourself. Different cultures and also entire countries have also different attitudes about schedules. So we need to keep those in mind when we're working in teams of like an integrated process team. So everyone's going to have different belief system or attitudes toward project management and managing those schedules. Okay, here's a little bit of statistics here. In contrast to the 2002 Salt Lake City Winter Olympic Games, in Chapter 4, planning and scheduling was different for the 2004 Athens Summer Olympic Games and the 2014 Sochi Winter Olympic Games. There were many articles written before the opening ceremonies in Athens predicting that the facilities would not be ready in time. The Greeks even made fun of critics having construction workers pretend to be working as the ceremonies begin. But the games cost more than twice the planned budget. so that was not very good either. In 2014, the Winter Olympic Games in Sochi, Russia, suffered even a greater financial loss and was the most expensive game in history. Games in history, excuse me. Okay, so in time management, you're going to see a few of these terms in this project management process. Planning schedule management, that is determining the policies, procedures, and the documentation that will be used for planning, executing, and controlling the project schedule. Defining the activities, that's identifying those specific activities that the project team members and stakeholders must perform to produce the project deliverables. So that's your task, and you'll see that in your work breakdown structure as well. Sequencing those, that's identifying and documenting the relationships between each one of those tasks. Like this task has to begin before this one, or this one has to be, or two tasks or activities have to begin at the same time. Those kinds of sequencing. It's also a relationships. We'll talk about the relationships too. Okay, so you need to estimate the resources that you need to be able to complete those activities, such as how many people that you're going to need on a project team, who's going to perform those specific activities, and what kind of money is going to be involved, and all three of those constraints that are going to be involved as well. Next is estimating activity durations. How long is it going to take for an individual or for the team or individual to complete one of those activities? Is it going to take a day? Is it going to take a week? And so forth. And then you develop the schedule. You analyze the activity sequences, the resource estimates, and the duration estimates to create the schedule. And then last but not least, controlling that schedule. You control and manage changes to that project schedule. But once you develop the schedule, you're going to get a baseline. And so you will know how long it's going to take for you to complete each one of those tasks, and you'll get a timeline for the project completion. And that's when you get your baseline. When you start making changes to that baseline under controlling the schedule, you'll know whether you're going off schedule or not. Microsoft Project is really great for that, because if you start making changes to dates and times or resources, then it's going to show you. You can also take each individual task in Microsoft Project and tell it every now and then, maybe at a particular milestone or a meeting, it's like, okay, I'm 50% done, so you can mark that task 50% completed. So it's a good tool. Okay, and here is the project time management summary from the project start to finish. So you're planning the schedule, defining the activities, sequencing the activities, estimating the resources that you need, estimating the durations or the time that's going to take to complete those activities, and then you develop the schedule. And that's where you get your baseline. And then after that, you're just monitoring and controlling that schedule to see if you're meeting all three of those or balancing those three constraints. Okay. Planning schedule management. Your team uses expert judgment. Remember, you're going to have a team that comes from different areas. I'll call them SMEs, subject matter experts in their field. And a project team is usually an integrated team. That means they're coming from different areas in the organization to that would have a play, and they're also stakeholders in having that project completed. But they will all give you their expert opinions on how to proceed. Okay. So they're going to use their judgment, expert judgment, analytical techniques, and meetings to develop that schedule. And then schedule management plan should include the project schedule, model development, the schedule and methodology, level of accuracy and units of measurement, control thresholds, rules of performance measurement, reporting formats, and process descriptions. Okay, so when we're defining a task or an activity, that is the element of work that you find on that work breakdown structure that has an expected duration, a cost, and resource requirements. So activity definition involves developing a more detailed work breakdown structure and supports explanations to understand all the work that has to be done so you can develop some kind of realistic cost and duration estimates. Your activity list and attributes. Your activity list is a tabulation or a table of activities that are included on a project schedule. It includes the activity name, an identifier or a unique number, and also a description of that activity. The attributes provide more information such as predecessors, successors, logical relationships, lead and lags, excuse me, resource requirements, constraints, imposed dates, and assumptions related to that particular activity. Okay, predecessors and successors are what happens before that particular activity, what happens after it. So you may have to, you don't build, when you're building a house, you don't build the roof first. So what's is the predecessor of building the roof? What comes afterward is your successor. And then the logical relationships is you've got to build a foundation first. You know, you can just arrange it in the order that things need to happen in your project schedule, and then you can link them, because if you don't have one particular task completed, that may become a critical task or a critical path. That means if you get off of that particular task, if you break the timeline on that, or the schedule date, or not have enough resources applied to it, and then you end up busting the schedule. Okay. A milestone. Okay. This is like, you can break down your project into certain areas and have particular milestones where you want to make sure or have a status check on the whole project, how it's going. So it's a significant event that has no duration, and it can just occur at any time during that schedule. It takes several different activities and a lot of work to complete one milestone. So maybe halfway through your project or a quarter way through, you might have a status meeting, and you can make that a particular milestone. Phase 1, Phase 2, Phase 3, Phase 4, those kinds of things can be milestones. They're useful tools for setting schedules and goals, monitoring progress, and also examples include obtaining customer sign-off on key documents or completion of specific products. Some more information on projects that went wrong. The FBI had poor time management was one of the reasons behind the failure of a disastrous, unbelievable, expensive piece of vaporware, which was more than 4 years in the making or unmaking. The system was supposed to enable the FBI agents to integrate intelligence from isolated information silos within the Bureau. In 2006, the GAO said that the Trilogy project failed at its core mission of improving the FBI's investigative abilities and was plagued with missed milestones and escalating cost. Sentinel replaced Trilogy in 2007. During a test exercise in 2011, Sentinel also experienced 2 outages, and the FBI determined that the current hardware structure was inadequate. In 2014, the system still wasn't working well. Okay, for sequencing activities, that involves reviewing activities, determine their dependencies. A dependency or relationship is the sequencing of your project activities or tasks. You must determine what dependencies are there in order to use a critical path analysis. Remember, I said that critical path can actually make or break your project schedule and timeline. So there's 3 types: mandatory, discretionary, and external dependencies. Mandatory is inherent in the nature of the work being performed on a project, and it's sometimes referred to as hard logic. Discretionary is defined by the project team, sometimes referred to as soft logic, and should be used with care since it may limit later scheduling options. And then external dependencies involves relationships between the project and non-project activities. Okay, so your network diagrams. They're the preferred technique for showing activity sequencing. A network diagram is a schematic display of the logical relationship among and sequencing of your project activities. And when I'm saying project activities, I mean each individual task that's in that work breakdown structure. 2 main formats are arrow and precedence diagramming methods. And here's a network diagram for, let's say, Project X. So each one of these numbers are different activities. Well, A, B, C, D, E, F, G, those are your activities. The numbers are your sequencing. This first, this second, this third, this fourth. See, these 3 can happen at the same time, but you can't jump to 5 without going from 1 to 3 or 1 to 2. And so some of these tasks can happen at the same time. It says assume all durations are in days. A equals one day. B is 2 days. 3 is C day. C is 3 days. Excuse me. So by the time you finish or get to 8, how many days have you did you need to complete that project? Okay, arrow diagramming method, ADM. It's also called activity on arrow network diagrams. They're represented by arrows. Nodes or circles are your starting points and ending points of the activities. And they can only show finish to start dependencies. And here's the process for creating the AOA diagrams. Find all the activities start at node 1, draw their finished nodes, and draw arrows between node 1 and those finished nodes. put the activity letter or name and duration estimate on the associated arrow. Continue drawing the network diagram, working from left to right, looking for bursts and merges. Bursts occur when a single node is followed by two or more activities, and a merge occurs when two or more nodes precede a single node. Continue drawing the project network diagram until all the activities are included. And on the diagram that have dependencies, as a rule of thumb, all arrowheads should face toward the right. No arrow should cross on an AOA diagram. Okay, precedence diagramming method. Activities are represented by boxes. Arrows show relationship between activities. And they're more popular than the ADM method and used by project management software. And it's better at showing different types of dependencies. So here's your task dependency types. Okay, so task dependencies is the relationship between two linked tasks. You link tasks by defining a dependency between their finish and start dates. For example, contact caterers. Task must finish before the start of determined menus task. There are 4 kinds of task dependencies in Microsoft Project. Start or finish to start, signaled by FS. Start to start is SS. Finish to finish is FF, and start to finish is SF. So finish to start, you look at A and the A box and the B box. Those are tasks. So task B cannot start before task A finishes. Start to start, that means that task B cannot start until task A starts. And then finish to finish, notice task B cannot finish until task A finishes. See, it's on the arrow is on the right-hand side there. So task B cannot finish until task A finishes. And then start to finish, task B cannot finish until task A starts. Okay. And here's a sample of the PDM network diagram. So your A, B, C, D, they're all your different tasks. It kind of shows a logical diagram of what has to happen first, second, third, or at the same time. So next you want to estimate the activity resources. So resources are your people, equipment, and materials, and also sometimes the financial part. So before estimating the activity durations, you need to have a good idea of the quantity and type of resources that you need to be assigned to each activity. So consider estimating resources, how difficult will it be to do specific activities on this project? What is the organization's history in doing those similar activities? And are they required resources available? So you'll have what's called a resource breakdown structure. It's a hierarchy structure that identifies the project resources by category and type. Now, when you're estimating the duration includes the actual amount of time worked on an activity plus any kind of elapsed time. And effort is the number of work days or work hours required to complete the task. Effort does not normally equal duration, but it can. And people doing the work should help create the estimates, and an expert should review them. Three-point estimates. So instead of providing activity estimates as a discrete number, such as 4 weeks, it's often helpful to create a 3-point estimate that includes an optimistic, most likely, and a pessimistic estimate, such as 3 weeks for the optimistic, 4 weeks most likely, and 5 weeks for the pessimistic estimate. A 3-point estimate is needed for PERT charts and Monte Carlo simulations. So when developing the schedule, you use the results of the other time management processes to determine start and end date of the project. The ultimate goal is to create a realistic project schedule that provides a basis for monitoring the progress and the time dimension of the project. Important tools such as Gantt charts, critical path analysis, and critical chain scheduling and PERT analysis can be used. Okay, so we'll talk about Gantt charts. Gantt charts give you a standard format for displaying the project schedule and by listing the project activities and their corresponding start to finish dates in a calendar or a graphical format. And the symbols included in Gantt charts are like sometimes a black diamond could be a milestone, thick black bars. These things are the symbols are highly modifiable in Microsoft projects. So instead of a thick black bar, you can have a thin one, or you can have a different color. Same thing with the black diamond. But normally, or by default, black diamond is a milestone. Thick black bars are the summary tasks that go across the chart that shows you start to finish. And then you'll have lighter horizontal bars that have the duration of each one of your tasks. And then you'll have arrows, and those arrows are dependencies between the tasks. So this is a Gantt chart. And notice you'll have your task name. You may have the task written out. You may have some of them indented. Maybe you'll have a major task, and then you'll as a summary, and then you'll have individual tasks or activities within that summary. But notice it's starting on the August 2nd, must be on that Sunday. Monday must be the 3rd. And then it will go all the way to August 24th, I think. Looks like 24th or 25th. And this is in Microsoft Project. And here's another Microsoft Project or Gantt chart. And you guys will do this in your text as an assignment. I don't think the assignment had you add in your durations. So as soon as you add your durations in for each one of those tasks, then that's when you'll start seeing the Gantt chart pop up. It'll start populating it. So you'll see the summary task, your milestone, the arrows showing the dependencies, and then that's the individual task, each one of the bars, and there's your summary task that goes all the way across. Shows your start and your finish for all of those tasks or activities underneath. Okay, adding milestones to your charts. Lots of people like to focus on meeting milestones, especially for large projects, and then they emphasize what important events or accomplishments on your projects. And you're also meeting to pretty much get a status report on your progress. So normally you create a milestone by entering tasks with a 0 duration, or you can mark any task as a milestone. Milestones should meet specific criteria, such as they have to be specific, be able to measure them. They should be assignable. That means you can assign it to a particular group or team or a person or a resource. They must be realistic and they must be time framed. Okay, here's some best practices. Sean Anker suggests the 20-second rule in his book called The Happiness Advantage. People prefer the path of least resistance because it's easier. For example, if you have to wait in line 20 seconds to get a second scoop of ice cream, you might resist it. I don't know, 20 seconds, 20 minutes maybe, 20 seconds I'd wait. Anker recommends making it more difficult for yourself to be distracted by work by keeping email or websites closed while you're working. And you can also save time or save time by adding time to the distracting behaviors at work. And here's another sample Gantt chart. Notice your plan dates. So remember I said you can get a baseline. That's your baseline, the lighter colored bar. And the darker colored bar, black bar here, is your actual date. So you went outside what was planned there. You started late here on this one, ended late there. This one ended up a little late. This one started late. This ended late. So then your milestone slipped as well, and it slipped here as well. So you're behind on this project. So your critical path method is called CPM. It's also a network diagram technique used to predict the total project duration. A critical path for the project is the series of activities that determine the earliest time to which the project can be completed. It's also the longest path through the network diagram that has the least amount of slack or float, which is the amount of time an activity may be delayed without delaying the succeeding activity or the project finish date. Calculating the critical path. First, you got to develop a good network diagram. Add the duration estimates for all your activities on each path through the whole network diagram. The longest path is the critical path. If one or more of the activities on that critical path takes longer than planned, the whole project schedule will slip unless the project manager takes corrective action. Okay. So this is determining the critical path for project X. So path 1 is look at A, D, H, and J. So you're going this way. Going A, D, H, J. You add up the days, that's 14 days. Path 2, let's look at B, E, H, J. So that's 16 days. Path 3 is B, F, J. Straight shot. 9 days. Normally your critical path is that straight and arrow. Okay, so that's 9 days. So path 4 is C, G, I, and J, and that's 14 days. Since the critical path is the longest path through the network diagram, which one is it? path 2. So you're going 2, 5, 6, and J. So the critical path is path 2. It's going to take you the longest number of days. This one is the least amount of time, the 9 days. Okay, so a project team at Apple put a stuffed gorilla on top of a cubicle of the person currently managing critical tasks. The critical path is not the one with all the critical activities. It only counts for time. Remember the example of growing grass being on the critical path for Disney's Animal Kingdom. There can be more than one critical path if the lengths of 2 or more paths are the same. The critical path can change as the project progresses as well. Okay, using the critical path analysis to make your schedule trade-offs. So if you have free slack or free float, the amount of time and activity can be delayed without delaying the early start of any immediately following activities. Total slack or total float is the amount of time an activity may be delayed from its early start without delaying the project finish date or the planned project finish date. A forward pass through the network diagram determines the early start and finish dates. A backward pass determines the late start and finish dates. So here's calculating early and late start finish dates. Okay, free and total float or slack for project X. See the start, finish, that's planned, and this is late start, late finish. Then it'll tell you the total free slack, total slack. So you can use the critical path to shorten a project schedule. So there are 3 main techniques for shortening schedules. Shortening your durations of critical activities tasks, you can add more resources or change their scope. Crashing activities by obtaining the greatest amount of schedule compression for the least incremental cost, and then fast tracking activities by doing them in parallel or overlapping them. So you also need to update your critical path data. It's important to update the project schedule information to meet time goals for a project. The critical path also may change as you're entering the actual start and finish dates. And if you notice that the project completion date might slip, you need to go back and talk with whoever sponsoring your project and get their okay or their buy-in. You also have something called critical chain scheduling. It's a method of scheduling that considers your resources, your limited resources, when you're creating a project schedule, and includes buffers to protect the project completion date. And it uses what's called theory of constraints, TOC, and it's a management philosophy developed by Eliyahu Goldratt and introduced in his book called The Goal. It attempts to minimize multitasking when a resource works on more than one task at a time. And here's an example. The first one's without multitasking. The second one is with multitasking. So task 1 completed after 10 days. Task 2 after 20. Task 3 after 30. And with the multitasking, you've got task 1 is completed after 20 days, and task 2 is completed after 25 days. So they give task 1 and 2 um, and 3 5 days, and then uh, the next task 1, 2, and 3 5 days. Both are still completed after 30 days. Okay, so a buffer, you want to add a buffer into your schedule, and that's add an additional time to complete a task. So if you add a buffer there, then you're going to hopefully not go off schedule. And Murphy's Law states that if something can go wrong, it will. So you want to add, give yourself as much time as you can uh, to be able to complete tasks. Parkinson's law also states that work expands to fill the time allowed. And that's kind of true because we all kind of procrastinate sometimes as well. If you've got a deadline to do something and you've built in some extra buffer time in there, you're still going to use that buffer time to, when your deadline is, you're still probably going to use that buffer in there as well. Just because procrastination, and humans do that. In traditional estimates, people add the buffer in for each task, and if it's not needed, or whether it's needed or not, but it'll increase the chances of meeting the total project schedule if you do that. Critical chain scheduling removes the buffers from individual tasks and instead creates a project buffer at the end, or additional time added before the project's due date. You can also have what's called feeding buffers, and that's additional time added before task on the critical path. Okay, and here is an example of critical chain scheduling. So they've added some buffer at the end there. Notice your X tasks are done by limited resources, and FB is your feeding buffer. So it's added in some buffer here, here, and at the end as well. So here's a website. You can go check it out for some more information. Scheduling at healthcare clinics can be more efficient by using that critical chain scheduling. There was a hospital in Singapore decreased patient admission times by more than 50%. So go check out this website and find out exactly what they did right. They use critical chain scheduling. Probably add some buffer in there. Okay. I think we're almost done here. Okay, a PERT is program evaluation and review technique. It's a network analysis technique used to estimate your project duration when there's a high degree of uncertainty about the individual activity duration estimates. So PERT uses what's called a probabilistic time estimate. Duration estimates are based on using optimistic, most likely, and pessimistic estimates of the activity durations or that 3-point estimate. So here's the formula and example of the PERT formula. So it's PERT weighted average is the optimistic time, 4 times the most likely time plus the pessimistic time divided by 6. And so that's going to give you what's called a PERT weighted average. Okay, so the example is 8 work days times 4 work days, which is the optimistic is going to, the least amount of time you think it's going to take is is optimistic pretty much. 8 work days, most likely it's going to be 10 work days, and then the pessimistic time is 24 work days. So 8 work days times or plus 4 times 10 work days, which is the most likely time, plus the pessimistic time, 24 work days, divided by 6 is 12 days. So that is your PERT estimate. Okay, so agile and time management. So there are core values of the manifesto for agile software development are customer collaboration over contract negotiation, responding to change over following a plan, and then the product owner defines and prioritizes the work to be done within within a sprint. So collaboration and time management are designed into the process. Team members focus on producing a useful product in a specified time frame with strong customer input, and don't emphasize defining all the work before scheduling it. Here are some schedule control suggestions. Perform reality checks on the schedules. Allow for contingencies, add some of the buffers in there. Don't plan for everyone to work at 100% capacity all the time. Uh, Most people don't work at 100% capacity at any time, so you have to, that's why I say add some of that buffer in there. Hold progress meetings or milestone meetings with stakeholders and be clear and honest in communicating schedule issues. And controlling your schedule, your goals are to know the status of the schedule and try to influence those factors that cause any kind of schedule changes, and determine it, um, why is that schedule changed, and manage those changes when they occur. So some of the tools to control the schedule are progress reports, schedule a change control system. Remember we talked about CCB, project management software, including schedule comparison charts like a tracking Gantt chart can be used. Use variance analysis such as analyzing float or slack and to see if you're on time or not. And performance management such as earned value management, and you can read a little bit about that in chapter 7. And then also review the draft schedule and or estimated completion date in the project charter. So if it's off and you have, remember sometimes you're going to have to go back and forth and update that project charter. If you estimate the cost early on, you may have to go and update that with the actual cost later. Same thing with anything else, especially their schedule. And you can prepare a more detailed schedule with the project team. Make sure that the schedule is realistic and followed. And then you also alert top management in advance if you see that you're coming up on some schedule problems. Okay, strong leadership also helps projects succeed more than PERT charts. So project managers should use empowerment, incentives, discipline, and negotiation skills. Using software to assist in time management. Software for facilitating communications help people exchange schedule-related information. Decision support models can help analyze trade-offs that can be made. And then project management software can also help in various time management areas. And next we've got global issues. Microsoft has a customer story of Mexico's Secretary of Economy, who wanted to ensure that the IT initiatives aligned with business goals and improved project management efficiency. After implementing the new software, their IT team could handle 4 times the number of concurrent projects without adding more staff. So, on using project management software. Many people misuse the project management software because they don't understand the important concepts and have not had training. You must enter dependencies to have the dates adjust automatically and to determine the critical path. You must also enter the actual schedule information to compare planned versus actual progress. Okay, so your chapter summary, project time management is often cited as the main source of conflict on projects, and most IT projects exceed time estimates. The main processes include planning your schedule, defining your activities, sequencing those activities, estimating the activity resources and durations, develop the schedule, and then control the schedule. Okay, that's it for this chapter, and I will talk to you on chapter 7.